Hello class, today we're going to be learning our first two lessons in chapter 11 and they're based on circles. The first one is talking about circumference of a circle and also the arc length of a circle. So first let's just talk about circumference. When I think of this word and what I want you to think about is the distance around a circle. So if you had a tape measure and you were going to wrap it around a circle, how long would it be to go all the way around? And so the formula that we have for this is we write capital C for circumference, and we would say that it equals pi times d, which is the diameter, that means all the way across the circle, or you can calculate it by multiplying 2 times pi times the radius of the circle r. So let's go ahead and do two examples. The first one, it says to find the circumference of a circle that has the radius of 9 millimeters. So let's write down our formula. Circumference equals, since it's giving me radius, I'm going to say 2 pi r. And so that's 2 times, for pi, we're going to use 3.14, and the radius is 9. And so this is going to be very, very close to 56.55 millimeters. And that's it. Pretty easy. Okay? It's nothing that you haven't done before, plugging stuff in. The second problem that we're going to do is we're going to be asked to find the diameter when we're given the circumference that's 36 feet. So again, let's write our formula. Circumference equals, well, since I'm looking for the diameter, I'm going to use the formula that has the diameter in it. So pi times diameter. And then let's fill in what we know. We know that the circumference is 36. And we know that we're going to use 3.14 for pi times d. Let's divide both sides by 3.14. And then we'll find that the diameter is going to be about 11.46 feet. And I would do that using my calculator. Okay? So that's circumference. It's pretty easy. Again, it's just the distance around a circle. But then you might be asked to find the arc length, which is actually just a specific length of an arc. So it's part of the outside of a circle. So let's write down specific length of an arc. All right, in our last chapter we talked a lot about arcs, and when we measured an arc it was in degrees. Well, now we're going to find out what that true measurement would be if we measured it with that tape measurer. So again, it might be in inches or in centimeters or something similar to that. So the formula that we're going to use to find the arc length, so in this case we'll say from A to B, is the measure of arc AB, which is the degrees that we would know it as, divided by 360 degrees, that's the total number of degrees in a circle, times 2 times pi times the radius. So basically, this right here times the circumference. So, if we are asked to find the arc length of EF, which I already have drawn for you here, let's go ahead and write our formula. So, arc length of EF, okay, is going to be the measure of the arc from E to F. So since since the angle right here is 60 degrees, that also means that this arc is going to be measured at 60 degrees. And using my formula, I'm going to divide by 360 degrees. And then I'm going to multiply by 2, by pi, and by the radius, which is 11. So when I go ahead and plug all those into my calculator, I'm going to find that it's going to be close to 11.52 centimeters. And I'm done. So for our next example, what I want us to do is to find the measure of RS, which means in degrees, what is the measure of this arc from R to S? So we know that the arc length of RS would follow the formula that we have used before. So it's going to be the measure in degrees of arc RS divided by 360 and then multiplied by the circumference, so 2 times pi times r. And in this case, I actually know the true measurement of the arc length, which is 44. I don't know the actual measurement in terms of degrees, so that's going to stay just in terms of its points. But I'm going to multiply that by 2 times pi, and the radius is 15.28. Okay, so if I was going to treat this like an equation where I'm trying to get this alone, I would multiply both sides by 360 degrees, and I would divide both sides by 2 pi r. So let's go ahead and try that. So it's going to be 44 times 360 and divided by the 2 pi r, so 2 times 3.14 times the 15.28, and then I have the measure of RS alone. I moved everything else that was on the side over to the left, and once I do that, put it in my calculator, I'm going to find that the measure of this is going to be 165 degrees. And I'm done. So now let's go ahead and move on to the second part. 11-2 is where we're going to be asked to find the area, but also the area of different sectors in a circle. So first, let's just talk general about what area is. We know of different shapes. Area is the amount of space that covers an entire shape. Normally it's little 1-by-1 squares. So what we're going to write for area is simply to remind us that it is the space inside of a circle. And the formula to calculate the area of a circle is pi times r squared. So my first example is to find the area of a circle with a diameter that is 5 centimeters. So let's write down our formula. Area equals pi r squared. Pi, we're going to use 3.14. And the radius, well, that's going to be half of the diameter, so 2.5. And we're going to square that. And when I plug all of this into my calculator, I'm going to find that the area is pretty close to 19.63 centimeters squared. So don't forget the units now are going to be squared, because really it's how many little squares can you fit inside of a shape. The next example that I'd like you to try is to find the radius of a circle with an area of 28.3 yards. So let's write again our formula. Area equals pi times r squared. This time we know the area is 28.3, but we do not know the radius. So let's plug in our 3.14 and leave it as radius squared. Divide both sides by 3.14. And then we're going to find that this is just about 9. It's 9.01 in your calculator. And that equals radius squared. And then when I take the square root of both sides, I'm going to find that the radius is, well, it's just about 3 yards. And I'm done with finding the area. Or not the area, but finding the radius from the area. So the last part is talking about the sector of a circle. And when we're talking about the sector of a circle, we're really thinking of like a slice of a circle. Okay, how much area would a slice fill up? So it's going to be a slice or a region inside a circle. Okay, so to find the area of a sector, okay, we're going to take the measurement of that arc in terms of degrees divided by 360 degrees and multiply it by the area of the entire circle. which would be pi r squared. Okay. So here's my first example. We'll just look at part of it. Let's find the area of this blue sector. Okay. So if I was going to find the area, I'm going to definitely have to write out the formula. So it's going to be the measure of, if I'm looking for the blue sector, which is HJK, I'm looking for the measure of the arc HK, divided by 360 degrees, and then multiplied by the area of the whole circle, so pi r squared. So in this case, the measure of the arc, since I know that the inner angle is 100, HK is also 100 degrees, divided by 360 degrees, times 3.14, times the radius is 12, so 12 squared. And when I put all of this into my calculator, it's going to be pretty close to 125.66 units squared. Since it doesn't specify if it's meters or centimeters or yards, I'm going to put units squared. So now we can also use this to calculate the area of this pink sector. So this time I need to find the measure of this outer arc in terms of degrees, so HLK, and divide that by 360 degrees and multiply it by the area of the entire circle, pi r squared. So in this example, if I know that from H to K is 100 degrees, then all the way around would be 360 minus 100, so it's going to be 260 degrees, divided by the 360 degrees, times pi is 3.14, times the radius again is 12 squared. And when I plug that into my calculator, I find that it's close to 326.73 units squared. So I hope that this has been pretty straightforward for you, how to find the circumference of a circle, maybe just part of the circumference, how to find the full area of a circle, or just part of the area of a circle, which is called a sector. So come with any questions you have when you return to class.